Hi, this is a prototype version of my robot. I want my robot to shoot a ball into a cup. In order to do that, I need the velocity explained in the previous video, the pitch angle, which is also known as the vertical angle, and and I also need the yaw angle, which is also known as the horizontal angle. In order to calculate this, in this video, I'm going to show you how to calculate the yaw angle. I'm going to show you the equation over here. Here's the ultrasonic sensors and the target. Let me tell you about the ultrasonic sensors. The ultrasonic sensor sends out sound waves, which when it hits the target, it bounces back. And it measures the time in order to calculate the distance. And the ultrasonic sensor sees some sort of like this. And this isn't the exact picture, but it sees something like this. It has pockets. So if the target is over here, it won't be able to see it, versus it will be able to see over here even though it's farther out. This distance I'll call A. This distance I'll call C. This distance between the ultrasonic sensors I'll call B, which is also a good name for it because it can stand for base. This is height. This is W. Here's my canon. This is distance D. I know this distance, which using lots of parallelograms. Lots of parallelograms. I know that this distance is equivalent to this distance, which I'll call F. This is also W. We know this because we can use laws of parallelograms, and this distance is B divided by 2. This small line over here says that this is the halfway point of both sides. The things that we know is A, C, B, and F. The reason why I know F is because I created my robot so I can actually measure the distance of F. I know A and C because even though the ultrasonic sensor does not only tells you the distance but does not tell you where it is, I use triangulation to figure out where the target is, therefore telling me where the line's distance are. Now knowing this, knowing all this information I have enough to calculate this little triangle that I am about to put in green, which after I have this little triangle, it will be enough information to calculate this bigger triangle, which I'll put in red. I might as well mark this distance as W. Area of a triangle is equal to 1/2 base times height. area of a triangle is also equal to square root of P times P minus A times P minus B times P minus C, where P is half the perimeter, which is A plus B plus C divided by 2. We solve for height. So this is a valid statement to say 1/2 base times height is equal to square root of B times P minus A times P minus B times P minus C. So we solve for height. Height is equal to 2 times square root of P times P minus A times P minus B times P minus, that looks like a D very much, P minus C, all over by B. This is our height formula. It will always be it. I'm gonna put a box around my answers so I can check back on them. Now that I know my height, I know my distance A, now I have enough to solve for the distance of W. We know that we know that in triangles, in a right triangle, the larger distance squared is the sum of the other two distances squared. So in that case, we can say that A squared is equal to H squared plus W squared. We want W, so we subtract W. So we subtract H from both sides and take square root of both sides. So W is equal to square root of A squared minus H squared. I'm going to put a box around that. Now that we have our W, we have everything in the little triangle. Now I can solve for the big triangle. I'm going to solve for D. D squared, you know what, before I solve for D, I'm going to make a variable for this full distance over here, which I'm going to call L. L is equal to B over 2 plus W. I'll explain later why I created this variable. Now I'm going to solve for D. D squared equals H plus F squared plus L squared. H plus F is in parentheses. D is equal to square root of H plus F squared plus L squared. Now that we have our distance, we can use a sine or cosine or tangent to find out our distance. I'll use a sine.
Is that P or D?
This, over here, this is a D. As I was saying, I'm going to solve for, there's this angle over here is alpha, and I need my distance and the vertical angle alpha. Now, sine of alpha is equal to H plus F over D. Now you take arcsine of both sides, so you can say that alpha is equal to arc sine of H plus F over D. Now that we have alpha, I'm going to put a square around it. I'm going to draw all my pictures from here on out in red or green, but I'm going to draw any calculations I have in black. So now I know that it works over here, but what happens if I move it? I know that my canon will be able to shoot over here like this, but what happens if it's, will the same calculations work if it's shooting like this? So that's what I'm going to find out right now. After I find out if it works like this, and then do the middle, and then start. So in other words, I'm going to move my target to the, start moving my target to the right. Here are my two ultrasonic sensors. I'll move them a little bit so it can be easier to see. Here's my target. A, C, B, that's the middle point. Here's my target, this is D, this is F. It'll go all the way down there. This is B over 2. Now, let me, oh yeah, this A in this case is also H, according to the picture. But yeah, this angle is alpha. Now I'm going to check if I'm going to check pretty quickly if everything is still okay. Still calculated the same way. This is good. This is, W is okay. Even though it's 0, there's that effect, no. Nothing not out. This is still okay. Yeah. It doesn't seem to be affected in any way. First thing I checked was P, because height is based on P, which lead to other places. So P is still okay, unaffected, and height is still unaffected. The only way that I think that P can be affected, the height can be changed or affected, is if A or C or B, or in other words, if this is no longer a triangle. That's the only time when P or H will be affected. So I'm not gonna, L is still okay, W and W is still okay. W is 0 now, so L is half of the base. That is correct. Distance is still okay. Okay, and alpha is still calculated the same way, so everything is good. I'll move on. Here are my two ultrasonic sensors. Here's my canon. Here's the middle point. This is B. Here's the target. This is A and C. This is my height. This is my distance. This is my F. My W is now over here from this dot to this dot. That's now my new W on this. And this is now my L. Now I'm going to check if everything's okay. It's still a triangle, so P and height is still okay. Alright, my W is still calculated the same way. It's still fine. Is L still okay? No, L is not okay. L used to be B over 2 plus W, versus if we still continue saying that, we're going to get this distance for L, versus L is really this distance from there to there. So we must say L equals B over 2 minus W. I'm going to write it down over here.
I might actually just use the same color pen as your triangle. It's easier to associate what you're writing and how you get there.
Okay, got it. So I can use an if condition for L is equal to B over 2 minus W. I can use an if condition when I go to program it, but instead I can use this and an if condition, but instead of doing that, I'm gonna create a new variable called S. S is equal to C squared minus A squared minus B squared divided by absolute value of C squared minus A squared minus B squared. On a right triangle, C squared is equal to A squared plus B squared. On an acute triangle, C squared is not equal to, but less than A squared plus B squared. This is C, this is A, this is B, this is C, this is A, this is B. C squared is greater than A squared plus B squared on an obtuse triangle. Now all three of these are true, depending on what size the triangle is. I'm not going to erase that so you can have a reference. Now I'm going to say L is equal to B over 2 plus SW. The reason why I call this S, so I can call it sine. Don't confuse this sign with this sign. This sign is used for trigonometry, versus this S for sine means like as using like minus or plus sign, versus this is something different. I'm going to box the answer. Now that we have L proper, it should work. Sine is less than 8. This is negative, this is minus, so that will be correct. L is correct. D is just fine. And alpha, which is right over here, is just fine. Everything is good now. Oops.
So isn't sine undefined? What happens when
Oh, you mean what happens when it's a right triangle? True, sine is undefined because if you try and do this equation when it's a right triangle, see, this will be 0 over 0, which is undefined.
So what should L be, or how would we get our distance if that's undefined?
I'm going to have to use an if condition in order to do that on my equations. I was trying to avoid using if conditions as much as possible, but I'm going to have to use this if condition. So now moving on. Here's one. Here are my ultrasonic sensors. Here's the canon. This is B. B is over here. This is my target. This is A. This is C. Here's my distance, D. And here's my angle, alpha. And now this over here is F, and over here is H. Oh yeah, W. This over here, half of W in this picture, is now half of B. Half of my base. And let me walk through this and you'll see the reason why you cannot see this picture. These, they're still a triangle, so these are true. W is still calculated the same way. L is B over 2. No, wait, L is not correct over here. I'm just going to go through this in red so that you can see which one is correct, as in which one I'm using. I'm going to go through this one too. And so this is the L that I'm going to use in my when I go to program it. L is B over 2 plus S of W. S is negative. S would only be 1 or -1 in these calculations, or undefined. L is equal to B over 2 plus S of W. S is -1 in this case, so L is B over 2 and W is half of the base, which is half of B. So L equals B over 2 minus B over 2, which is L equals 0. That's why you can't see it. That's correct on this picture. Though these are now H plus F, square root of H plus F squared. So the square, since there's only one square, the square cancels out with the square root. So D equals H plus F. Arc sine of H plus F over D is something divided by itself. So that equals 1. Arc sine of 1 is 90. So alpha is 90 degrees, which is true in this picture. Now I'm going to switch to pen color again. You know what? I'll keep using, you know what? I'll use purple. Now. Hold on. Let me lock the door so there's no distractions. So now I'm using purple. You have the two ultrasonic sensors. Here's distance B. I'm going to put it on this side so it's out of the way. Here's the halfway mark. Here's the target. Now this is A. This is C. Here's my canon. W is now all the way over here. This whole thing is W. This is distance D, which I can show it over. I'm going to move this back a little bit. This is F. This is our height. Now W is all the way over here. This is W, not squiggly lines, but W. And B, I'm going to move it up here so it can be seen easier. I'm going to check if everything's okay. These two are okay because it's still a triangle. W equals a squared minus a squared, that's still fine. L is equal to b over 2 plus s of w. L is the negative value, so L is this over here. I think that might affect our calculations. Let me check. Luckily, anything times itself is equal to a positive number. So D is not affected, but alpha, it seems that since we're using this triangle, we're using the wrong triangle. We're not calculating based on this. We're not getting this angle over here, which is alpha, but what we're really getting is what I'm going to put in black. What we want isn't red on this picture, but what we're really getting is over here. This black angle, which I'll call, what should I call it? I'll call it epsilon. Now that you have alpha, what I want is that I don't want epsilon, but I want alpha, so I'm going to say alpha is equal to 180 minus, oops, let me erase that so I can actually make it look like it's 180. I'm going to use changing my pen color to keep it associated. Alpha equals 180 minus theta. I might just have to use another if condition, but I'll check later. After I finish solving the rest of it going right. So now that I have that, I have my alpha. Besides that, if I use an if condition over here, alpha is okay, so I'll keep moving it back.
I'm sorry, what kind of if condition? If what? What is your if condition? You keep saying you use an if condition.
And for the alpha, the if condition is if alpha is greater than 90 degrees, alpha is equal to 180 minus, oops, this is supposed to be epsilon, not theta. I accidentally said theta and put that there, but it's supposed to be epsilon. Alpha equals 180 minus epsilon.
So how do you know when you should subtract?
I know that when alpha is greater than 90 degrees, the L is a negative value because W is greater than...
So you're going to get alpha with greater than 90 degrees over there?
No, but I'm going to get epsilon as my value for the angle. First I'm going to check if my L is negative. If my L is negative, I'm gonna say that alpha is equal to 180 minus epsilon. And I'm gonna say epsilon is equal to the angle when L is negative.
Can you write it in an expression? Because I think that's an important information that we didn't see there.
If
Is or if?
I'm going to put if L is a negative value, then alpha, then arc,
I'm sorry, you don't need to write the code. Can you put it in a math expression?
so like if L is a negative number, arc sine of H plus F divided by D is is an arcsine of h over f plus d is equal to epsilon, and alpha is equal to 180 minus epsilon. So, knowing that, I think it would actually be a good time to actually solve for what alpha would really be without having to use an if condition. I'm going to do this in black. I think knowing that L can be positive or negative is actually what we need, and is some of the things that we need. And looking at this, I know how we're solving for alpha. So I'm going to start off small and move to the rest of the equation. I know that alpha something. I know that I need theta in here somehow, so that when L is negative,
I'm sorry, theta?
I mean epsilon. Epsilon is in when L is a negative value, alpha is equal to 180 minus epsilon, and when L is a positive value, alpha is equal to epsilon. So what I can do is check for L if it's -1 by saying L over absolute value of L. That would either give me 1 or -1, and then I multiply that by 90. Wait, negative L over absolute value of L. If L is a negative value, and actually turn it to positive, and I can say, and I multiply that by 90,